But I just wanted to remind you what you did in the class. So I said we were going to talk about problem solving and logic and planning and learning and probabilistic reasoning, and we did. And you guys now know about combinatorial search, and you already knew about propositional logic, but now you know about first order logic and Markov decision processes and hidden Markov models and Bayes nets. So you guys have covered a lot. So congratulations on getting through it all. This last end of lecture question was, hey, talk about your AI group. How does it work? How do you get involved? How much work is it? So if you want to get involved with AI, there are a number of things you can do. There are a bunch of us, like Scott's not the only one. There are like 8 other people who are crazy enough to think AI is kind of cool. And we like get together in a secret room every week and meet and talk about papers and what people are working on. And in fact, it's not even secret. You can actually Google UNH AI group and you'll get this URL. And if you go to it, you'll find out where we're meeting. We'll meet throughout the summer and we'll meet next fall. Next fall, I'm not teaching an AI class, but next spring I'm teaching a class on robot algorithms. So if you think Scott's stuff's interesting, you should check that out. There are other folks at UNH that teach stuff that's kind of related to AI, like Matt, who's busy working with his plumber to get his sink to work, is doing an independent study with Sylvia on natural language processing, which some people call computational linguistics. Andrew Kung teaches a neural net class from time to time, and Rich Messner knows something about image processing, and Mei Win supposedly knows stuff about control theory, and those all relate to AI to certain degrees. Val Schmidt over at CCOM actually has a robot, although it's not here very often because it's like very expensive, so people are off using it all the time. But he's interested in talking to people who are interested in robots. There's some folks over in cognitive psychology that are interested in how the mind works. There are folks in philosophy who are interested in philosophy of language and philosophy of mind and the limits of computer reasoning. And there are folks in the math department who are interested in logic. So there are lots of ways to, if you're interested in topics in this class. I'm always happy to talk to folks about doing research. UNH even pays people to do research. There's an undergrad who hasn't even taken this class yet who's getting paid by UNH to do AI research this summer, which is quite amazing. So if you want to get involved with the AI group, you could take it as an independent study if you're an undergrad, I suppose, if you want to do something before the spring. And it's however much work you want to put in, unless you're taking it for credit, in which case it's tons of work, because you know me. What kind of stuff do we do at UNH? This kind of stuff. There's a lot of work on suboptimal heuristic search. All kinds of different kinds of suboptimal. So we talked about A star, which is optimal, right? And so it takes forever because it has to look at every node whose H value is less than the cost of the, or F value is less than the cost of the optimal solution. So what happens if you are willing to be suboptimal, but you're not willing to be totally awful? You want to have bounded suboptimality, for example, where you say, I want to be within 10% of optimal. So how do you do that fast? Jordan Thayer is getting his PhD in 2 weeks for a thesis on this topic. He also has a paper on cost-bounded search. So not what if you want to bound your suboptimality, but what if you want to come in like less than $10? Contract search is a suboptimal search where you are given a certain amount of time. Like it's search for 1 minute and then give me the best solution you can. So that's very like how do you have an algorithm that uses 1 minute most effectively? Which node should you expand next if you have only a minute? That's a very interesting problem. And then this is my thing that's most exciting at the moment. Ethan Burns is doing his PhD on this, and we'll finish up next year, on not what if you want to find the shortest plan, or what if you want to find a plan as quickly as possible, that might be really bad, but what if you want to achieve the goal as soon as possible? So the sum of planning time and execution time is as short as possible. How do you do that? Rather than quickly finding a really long plan or spending a very long time finding a short plan, spend some time planning and some time execution so you get to the goal as soon as possible, because that's what you really care about in a lot of applications. Like, for example, if you're a robot. So that's cool. Scott's working on motion planning. Matt's working on parallel and external memory search. I have a master's student graduating who's working on something called hierarchical search, which is what you do if you don't have a heuristic. How do you do heuristic search if you don't have a heuristic? How do you get a heuristic value if someone hasn't programmed in something? Oh, God, what do you do? Well, of course, the answer is you do more search. You automatically derive a simplified version of the problem, and you do search from the abstract start to the abstract goal, and then that gives you a heuristic value, a lower bound on the cost of the real solution. So it's search inside search inside search in a hierarchy. And there's other stuff too, but